In this illustration, we intend to simulate the oblique impact of the ball into the water in the Abaqus software. In this question, the ball is thrown with the initial velocity of 2 meters per second and at 45 degrees and then enters the water. Here, since the throwing angle is 45 degrees, the impact angle will be 45 degrees as well, and so the ball will be entered the water at the angle of 45 degrees. Here, the animation of this process can be clearly observed. I will click on Create Part. I intend to create the geometric shape of the ball. I will select the modeling space as 3D. From here, Deformable, then select Shell and Revolution, enter approximate size equal to 0.1 and continue. Here, I will draw a semicircle. I will enter the radius of the circle equal to 0.015 meters. Done. I will enter the angle of rotation equal to 360 degrees and OK. In the next step, we should create partition over the ball. I will click on Tools menu, select Datum. From here, select Plane and then 3 points. Then I will select these 3 points. I will click on Tools menu, select Partition. Here select Face and then Datum Plane. Select this datum plane and then click on Create Partition. In the next step, I'll click on Points and Normal. First, select this point and then this line. In the next step, I will select Use Datum Plane option. Select the whole of the ball. Done. Select this datum plane and click on Create Partition. In the next step, I'll click on Create Part. I intend to create a Eulerian part. Here, I'll select 3D, then Eulerian, enter approximate size equal to 1, and continue. I will draw a rectangle. I'll enter its length equal to 0.4 meters and its width equal to 0.25 meters. Done. I will enter its depth equal to 0.25 meters and OK. I will click on Tools menu, select Datum. From here, select Plane and then Offset from Plane. Select this face, enter value, flip OK, then enter offset equal to 0.09 meters. After that, I will create partition over part Eulerian using this data template. In the next step, I will enter property module. Click on create material. I intend to define the properties of water. I will click on general menu, then on density. The density of water is equal to 1000 kilograms per cubic meter. Then I will click on mechanical menu, select EOS or the same equation of state. From here, select USUP. The sound speed in the water is equal to 1500 meters per second. In the next step, I click on a mechanical menu, select viscosity. The dynamic viscosity of water is equal to 0.001 Pascal second. OK. I will click on create section. Here, select solid and Eulerian. Continue. Then here I will select water material and OK. I'll click on assign section. OK. I'll click on create material. Here I intend to define the properties of steel. Actually, the bowl is made of steel. I'll click on general menu, then on density. The density of steel is equal to 7,800 kilograms per cubic meter. In the next step, I'll click on mechanical menu, select elasticity and elastic. The Young modulus is equal to 200 multiplied by 10 to the power of 9 Pascal, and Poisson ratio is equal to 0.3. OK. I'll click on create section. Here select shell and homogeneous. Continue. I will select the steel material. The thickness of bowl is equal to 0.5 millimeters. OK. I'll click on assign section, select the bowl, done, and OK. I will enter assembly module, click on create instance, enter both parts of Eulerian and ball into the assembly section and OK. I will click on translate instance, select the ball, done. First select this point, then this one and OK. I click on translate instance, select the ball, done, and keep it away as much as 0.3 meters from Eulerian part. In the next step, I'll enter step module. Click on create step. Here select dynamic explicit, continue. Time period is equal to 1.8 seconds and OK. I click on Field Output Manager, Edit. Here I will enter the number of outputs equal to 360 and OK. In the next step, I'll enter interaction module. I will click on create interaction property, select contact, continue and OK. Then I'll click on create interaction, select general contact, continue. Here I will select interaction property we had created in the last step and OK. In this manner, the interaction between water and bowl was defined. In the next step, we should convert the formable ball to a rigid ball. I'll click on Tools menu, select Reference Point, select this point. I'll click on Create Constraint, select Rigid Body, Continue. Click on this arrow, then select the ball, done. Here I will click on this arrow, select the reference point of the ball and OK. In this way, the deformable ball converted to a rigid ball. In the next step, I'll enter load module. Click on create boundary condition. Here, select initial step, then select velocity, angular velocity, and continue. I will select these surfaces. Done. Here, I'll close boundary condition of V1 for them, and OK. I'll click on create boundary condition again, select velocity, angular velocity, continue. Select these surfaces. Done. Then select boundary condition of V3 and OK. I'll click on create boundary condition, select velocity, angular velocity, continue. Select the bottom of Eulerian part, done, and close boundary condition of V2 for it. In the next step, I'll click on create predefined field. Here select initial step. In the category section, I'll select mechanical option, then select velocity and continue. I'll select the reference point of ball, done. Here the ball will be thrown with an initial velocity of 2 meters per second and at an angle of 45 degrees. So the velocity of the ball directed at x-axis is equal to 1.4142 meters per second. And the velocity directed at y-axis is equal to 1.4142 meters per second. So the ball will be thrown with the initial velocity of 2 meters per second and at an angle of 45 degrees. In the next step, I'll click on create load. Here select step 1, then select gravity, continue. The acceleration of Earth's gravity is equal to negative 9.81 meters per squared second. OK. Thus, the weight of the ball and water will be considered in this problem. In the next step, I'll enter mesh module. Here click on seed part and enter approximate global size equal to 0.003 meters and OK. I'll click on assign mesh control. Select the ball, done. Here select quad, then structured and OK. Then click on mesh part and yes. I'll click on assign element type, select the ball, done. Here put element library on explicit and OK. I'll click on seed part, enter approximate global size equal to 0.0035 meters. OK. Then click on mesh part and yes. I'll enter load module. Click on create predefined field. Select initial step. In category section, select other option, then select material assignment. Continue, select Eulerian part. Here, I'll right click and select edit region. Here, we should select the area in which water exists. As you know, the lower of Eulerian part has been filled with water and the top part of that is void. So I'll select the bottom section as water. Done. Here enter number 1 and OK. Actually, here the area having water has been marked out with pink color. Here I'll save the model. I will enter job module. Click on create job. Continue. OK, and click on submit. The analysis was done successfully, so I'll click on result. As you observe, the ball enters the water after hitting the water, then comes up to the surface again, goes into the water once again, and keeps moving up and down until it is balanced on a fixed point. Another point here is that the waves cause the ball to move forwards or to the right side, and as it can be observed, here is where the ball impacts, but the waves cause the ball start moving forwards and towards these areas.